All right, here is a problem from your homework from yesterday. I said, here is a problem from your homework from yesterday. I like to go back over it with you to make sure that we are on the same page, first of all. Okay, and make sure you remember what we did yesterday. Okay, so what do? You want to condense, right? We want to condense. We only want the word log written once if we can help it, right? So how do we condense this left-hand side of the equation? Log base x of 12 times 18, like that. Do we know what 12 times 18 is? Okay, so log base x of 216 equals 3. And then what? So it's already in logarithmic form, so we want to try to solve it using exponential form, right? So x to the third equals 216. Well, we know how to solve that, right? We've already done cubic problems, haven't we? So we solve it with cube root. So if I take the cube root of both sides, x equals, not this time, just 6. Okay, it's not plus or minus 6 because we only have an odd root. Okay, only when there's an even root do we have to worry about plus or minus. Okay, so is that right? Could we check it to make sure? So log base 6 of 12 plus log base 6 of 18. And what should it equal? Ta-da! I know without a shadow of a doubt that that's correct, right? You okay with that? All right, here's another one of our problems from yesterday. How do we solve this one? Log base 9. Yeah, because we took this 4 and brought it back up as an exponent of the argument, right? So 3 to the 4th. Do we know 3 to the 4th? Yeah? What is it? 81. Now, how would you go about solving this? You could do that. If we wrote it in exponential form, that would be 9 to the x power equals 81, right? And we just happen to know that that answer is 2, right? Except, what if the base was not 9? What if it was like 6? Is writing it in exponential form the best way? No. Guys, if this says log base 9 of 81 equals x, and it's asking you to solve for x, you've already solved for x, haven't you? Is there a way that you can get the value of 9, or log base 9 of 81? Yeah. I said, yeah. Log base, not that. Log base 9 of 81. And just like we thought, it's 2, right? But we could put this right here straight into the calculator. I'm glad that you're thinking go from logarithmic to exponential, because in problems like this, that's how we have to solve it, right? But when it equals the x, it's already in a situation where we can use our calculator to solve it. I'm also glad that you're using your brain and seeing that 9 squared would be 81. But like I said a second ago, they're not always going to be all that nice. Sometimes the base is going to be 6. And 6 to what power equals 81? I don't know. That's why we have to be able to use logarithms. Okay? Any questions? So that brings us to today's examples. Okay? There are some of these on the homework because I need to make sure that you're comfortable with these. So we're going to do a couple more of these. Okay? But there's also some on the homework that look like this. Oops. That's supposed to be an x. Pretend that's an x. How are you going to go about solving that? Well, you could. But if we're writing going from logarithmic to exponential form, Would it make sense then, if it's already in exponential form, to try to go to logarithmic form? I mean, would it make sense? That's one of the reasons why at the very beginning of this chapter we did so many examples of going from logarithmic to exponential and exponential to logarithmic. So that when we got to a situation like this, we would know immediately that it was log base 4 of 7 equals x. Well, we don't know how to solve this top one, but this bottom one is super cinchy, isn't it? How do we solve that? Straight in our calculator. Okay? Log base 4 of 7. Now, I'm not saying it's cinchy because I knew it off the top of my head. I did not. Okay? I'm saying it's super cinchy because it's something that we can put directly into our calculator. Or we could use our log tables if you knew how to use log tables, but nobody wants to do that. No, you don't. Just trust me on that one, okay? So x is going to equal 1.4037. Because today we're going to go to the 10,000th power. Decimal. Tens, hundreds, thousandths, 10,000ths. Okay? We're going to 4 decimal places. But I didn't say go to 4 decimal places because on a standardized test it's not going to say go to 4 decimal places. It's going to say round to the 10,000th. And you need to know that's 4 decimal places. Is that fair? Okay? So, is this right? We should check it, right? Okay. 4 raised to the 1.4037 equals 7. It says false. Did we do something wrong? What if we just did 4 raised to the 1.4037? That's really close to 7. Why is it really close to 7? Because we rounded. Okay? So if you put it straight in like that, like we've talked about doing before to check, where it'll tell you true or false, sometimes it might tell you false when in actuality we got the right answer, but we rounded. So just be careful with that. Probably just put in one side and see if it's that answer or something very close to it like this one is. Does that make sense? Yeah? Okay. Now let's see. I'll make you a really difficult one. How about that? Okay. 2 to the 4x power plus 7 equals 13. So is this really difficult? Now what do you want to do first? Subtract 7, good. 2 to the 4x power equals 6. Now what? If it's an exponential, where do you want to take it? Logarithmic, right? So log base 2 of 6 equals 4x. Now what am I going to have to do to solve for x here? I'm going to have to divide everything by 4, right? As long as we're careful, we can put that whole thing in just like it is. I'm going to put a fraction, and I'm going to say log base 2 of 6 divided by 4. And that's my answer. X equals 0.6462. Is it right? 2 raised to the 4 times 0.6462 plus 7. Is it correct? Is that close enough to 13? Yes, it is. Okay, we know there's going to be a slight error because of the fact that we rounded. Okay? Any questions? Now, there's one of these problems on your homework that every year people freak out about. So I'm here to tell you to not and show you why you should not. Okay? Log base 4 of 2x equals a log base 4 of x plus 15. Why do they freak out, first of all? There's 2 logs. Except there was 2 logs in this problem. Did you freak out about that?
This is Kingston.
Yes, sir.
Do you have Taylor Angela?
Yes, I do.
Can you send her to the office, please?
Yes, I will.
Thank you.
Hey, you need to go to the office. You need to go to the office. Okay. So why do we freak out at this one, but not freak out at this one? Well, you knew what to do on this one, right? You knew you had to. You knew you could condense them and only have 1 log, right? Except this one is even easier. Like, seriously. If log of this equals log of this, shouldn't those 2 things just equal each other? So couldn't I solve the equation 2x equals x plus 15? And that's an equation you've been solving since 8th grade or earlier. X equals 15. Is that something to freak out about? No, it's not. Not at all, right? Any questions? Any questions? Now, is it right? You should check, right? So if I put 15 in right here, I get 30. So log base 4 of 30. If I put in 15 right here, I get 30. Do I have to know what log base 4 of 30 is? Or is it good enough for me to know that log base 4 of 30 equals log base 4 of 30? That's good enough, right? I don't have to know what log base 4 of 30 is because I know both sides equal log base 4 of 30. So I checked that one without even having to use the calculator at all because I used my brain. Most of you have one, yes. Well, you all have them. Most of you use them sometimes. Not a lot sometimes, but. Does everybody understand? So you have some that are like this right here. You have some that are like this right here, and then you have a couple that are like this. Okay? Ask questions if you need to. My book is open in the back so you can check your answers as you go. But definitely work with your group and ask, like I said, ask questions if you need to, okay? Peace.